Hello, class 12th physics VIVA questions. Examiner can ask questions from any of the topic, but here there are a few basic questions which you must know. So, what do you mean by electric current? So, the answer is when electron flows through a wire, then it forms an electric current. And in quantitative form, the rate of flow of electric charge is called electric current. How do current flows through a conductor? So the answer is when potential difference is applied across a conductor or a body, then the electrons moves under the influence of the electric field produced by the cell or the battery or the potential difference source, a constant potential difference source, which makes the electron move in the direction opposite to the electric field, and it forms an electric current. In this process, electrons drift drift opposite to the direction of electric field and continuously collide with the constituents of the conductor or the atoms of the conductor with a velocity which is called drift velocity. Name the types of velocities possessed by an electron in a current carrying conductor. So when there is no potential difference applied across a conductor, then electrons move with thermal velocities in a random motion, in a zigzag kind of motion. But when potential difference is applied, then they acquire drift velocity. The direction of drift velocity is opposite to the applied electric field across the wire due to applied potential difference. It has very small order of 10 to the power minus 4 meter per second to 10 to the power minus 3 meter per second. Electric current has a conventional direction, but it does not follow the vector sum rule. And in fact, it follows algebraic sum. So it does not depend upon the angle between two or more current meeting at a junction, unlike force or any other kind of vectors. Resistance of a body or a device is the obstruction offered by it in the flow of current. Or mathematically, it is the ratio between potential difference and current flowing through that body. And resistivity is related to the material of that device or body or a conductor, and it is numerically equal to the resistance offered by unit area of cross section and unit length of a conductor or a body. Moreover, resistance depends upon the geometric shape and size of an object, whereas resistivity is the inherent property of a material. And but there is a similarity also. Resistance depends upon temperature, and resistivity also depend on temperature in the same way. Uh, SI unit of resistance is ohm, whereas of resistivity is ohm meter. Name some material used to make standard resistance. So there are some alloys like constantan, mangnin, nichrome, which are used to make standard resistance. That is the resistance of fixed value by which we can measure some other resistance, or we can do our experiments. Why alloys like constantan and mangnin are used to make standard resistors? So first thing, these conductors have very high resistivity than their constituent metals or commonly used metals. Um, Secondly, their temperature coefficient of resistivity is very low. So if temperature varies, their resistance does not vary. Actually, their resistivity does not vary, so also their resistance does not vary. Next thing, they do not easily corrode, and that is why they are used to make standard resistors. Okay, what is the EMF of a cell? How is it different from potential difference, or to be more precise, terminal potential difference? So, the maximum potential difference across the terminals of a cell when it is in open circuit condition is called EMF. It is the maximum available potential difference by a cell. Whereas terminal potential difference is the maximum potential difference across the terminals of a cell or a conductor through which current is flowing when circuit is closed. So this is the difference between EMF. If we are talking about no current is flowing through the circuit, so it means maximum capability of potential difference, maximum capability of cell to provide potential difference in the circuit will be EMF. And when current flows, then actually entire potential difference which could be delivered from the cell is not being delivered in the circuit because some of its part is utilized by cell itself. So once again, I repeat, the maximum potential difference across the terminal of the cell is called EMF. So now it is quite basic, but I will tell about this. So the current flowing through a conductor is directly proportional to potential difference across it, keeping constant constant temperature and other physical conditions. So it is applicable for conductors only, and when physical conditions are constant. Okay, by giving example of each, distinguish between ohmic and non-ohmic resistance. So basically, we are talking about the object or devices through which current is flowing. So if voltage to current relation follows Ohm's law, then it is ohmic resistance, and if does not follows, then it is non-ohmic resistance. So ohmic resistance is all the metals at constant temperature, and non-ohmic resistance metals but at varying temperature, or in fact some very good conductors like silver at high current, because at high current their temperature will rise, and that is why Ohm's law will not be followed. But yeah, that then it will be non-ohmic. But all otherwise under controlled condition, all the metals are ohmic resistance. Non-ohmic, to be very precise, in all the conditions all the semiconductors are non-ohmic, and other than that gases are non-ohmic, electrolytes are non-ohmic, and of course insulators. This is a Wheatstone bridge. So it is an arrangement of four resistors forming the arms of a quadrilateral, so whose diagonals are connected to a cell and a galvanometer. Next, what is the balance condition of Wheatstone bridge? So I'm not drawing here it, but see, we can say that if galvanometer shows no deflection, then the adjacent sides of Wheatstone bridge has resistance in same proportion, or if they are labeled as PQRS, then P by Q equal to R by S. What is the application of Wheatstone bridge, or what is the use of Wheatstone bridge? So in Wheatstone bridge arrangement, if three resistors are known and if we achieve balanced condition, then fourth resistor we can find by using formula P by Q equal to R by S. It is a device based upon Wheatstone bridge principle. It has a 1 meter long resistive wire, and it is used to measure resistance by null deflection method. Of which material the meter bridge wire is made up of? So it is made up of some kind of alloy, like of a higher resistivity, like constantan, mangnin, or nichrome. What else a meter bridge is called? It is also called slide wire bridge. So generally meter bridge name is because it has 1 meter long wire, resistive wire, but it is also called slide wire bridge, and uh, because its wire can have any length, then meter bridge is not a suitable name on otherwise cases. Okay, if we stretch a wire to double its length, then how will its resistance and resistivity change? So first of all, if we stretch a wire or fold it over, then its resistivity will never change. So because resistivity does not depend upon geometrical shape and size, length, or area of cross section. But if we stretch the wire, then remember it will get thin laterally and its length will increase. So as resistance depends upon area of cross section and length, so area of cross section is decreasing, so resistance will increase because it is in inverse proportion, and length is increasing, so again resistance is increasing. So in such a case, if we stretch a wire, then resistance will increase. Here is a formula: new resistance will be n square times the old resistance, where n is the times how much times it is increased. It's like here it is doubled, then it will be 2 to the power 2, that is 4 times. If it would be 3 times increased, then 3 to the power 2, then it will be 9 times. And same for not double or triple, 1.5 times, whatever. Okay, define resistivity, give its SI unit. So resistivity of a material of a conductor is the resistance offered by unit area of cross section and unit length of that material. Okay, so it has a formula also. Rho is its symbol. Rho is equal to Ra upon L. Resistivity equal to resistance times area of cross section upon length, and its SI unit is ohmmeter. You can calculate it from its formula. So it has a very deep explanation, but in simple way we can say in series combination current remains same, that is why ammeter is connected in series. In the same way, someone can ask then why voltmeter is connected in parallel, because in parallel combination potential difference remains same. Okay, when is meter bridge most sensitive, and up to which range it has optimum accuracy? So meter bridge is most sensitive when the null point is obtained just at the middle of the resistive wire or meter bridge wire. So generally it is 1 meter long. So if null point is obtained at 50 centimeter, and if not, then the optimum accuracy range is from 30 centimeter to 70 centimeter. Okay, what is meant by internal resistance of a cell? What factors it depends? So the resistance offered by the electrolyte of the cell is called internal resistance of the cell, because cell itself offers resistance across the current which it is generating. Yeah, it depends upon concentration of the electrolyte. It depends upon nature of electrode, separation between electrodes, and the surface area of the electrodes. Galvanometer has resistance. Yes, of course it has resistance. It has, although it has a copper coil, but it has a finite resistance. Small, but yeah, it has resistance. Distinguish between galvanometer, ammeter, and voltmeter. So galvanometer detects current, presence of current. Ammeter measures current, and voltmeter measures potential difference. So basically, an ammeter is a galvanometer of negligible resistance, and voltmeter is a galvanometer of extremely high resistance. How will you convert galvanometer into an ammeter? So the simple answer is by applying shunt of suitable resistance. So what is a shunt? Shunt is a parallel resistance. So why shunt is used? Because a low resistance across galvanometer reduces the overall resistance. In the same way, someone can ask how will you convert galvanometer into voltmeter. So it is converted by putting a very high resistance in series with galvanometer. An ideal voltmeter and ideal ammeter. So ideal voltmeter has infinite resistance and ideal ammeter has zero resistance. So these are ideal condition. Generally it doesn't happen. So ammeter has very negligible resistance and voltmeter has quite high resistance. But ideally voltmeter has infinite and ammeter has zero resistance. Can we use a DC ammeter to measure AC? Why or why not? So answer is definitely not, because AC continuously changes its direction, and if we connect a DC ammeter, it will experience rapidly torque on both sides as per the frequency of alternating current, and it will because of the inertia of the coil and the pointer, it will not get deflected instantly on both sides. So it will look either vibrating at mean position with small amplitudes, or it would look stationary. Instead, for AC, heating type emitter is used. And similarly, if we want to measure voltage in AC circuit, the same kind of heating type of device is used. Heating type emitter and heating type voltmeter. So there are some formulae which can be asked directly, and you can give their answer. Relation between current and drift velocity. So I is Vna. You can memorize it by Vna. D is silent. Vd together is drift velocity actually. E electron charge. N number of free electron per unit volume. A area of cross section of wire. Remember that. And in the same way, resistance of a wire of a conductor is, you can memorize it by my love Tina. ml upon t tau EENA. Mass of electron and length of wire, tau relaxation time, charge of electron, n number of free electron per unit volume, a area of cross section, where tau depends upon temperature actually. How, I haven't covered it here. For galvanometer, there is current sensitivity, which is angular deflection upon current, and further it turns out to be NAB upon K, Nayab upon Kamyab, N number of turn, A area of cross section, B magnetic field, K is torsional constant or restoring spring constant of galvanometer. By the way, that torsional spring of galvanometer made up of phosphor bronze. Bye.